what a thread class is. First, a thread is defined as a program operating root. That is, every thread creates its own distinct control flow. Next, a threading reduces CPU cycle waste and it also improves a program's efficiency. Threads are created using a thread class, which lets you specify a thread's precedence, and it also displays a current status of the thread. Next, let's go over a few pointers on multi-threading. But first, let's understand what a single-threaded model is. Every program has a one thread that performs the logic of a program by default, and this thread is known as a main thread. Hence, every program or application is a single-threaded by default. But there is a disadvantage to these single-threaded architectures. The single thread executes all of the processes in a program synchronously, that is, one after the other. As a result, the second process needs to wait until the first process completes its execution. So, the second process will take longer to process. But to overcome this disadvantage, we have multi-threading. Multi-threading refers to the use of many threads inside a single process. Each thread here serves a separate function. So, the main advantage of multi-threading is that it operates concurrently, meaning numerous jobs may be executed simultaneously. Finally, a multi-threading also maximizes the CPU's resource consumption. Next, let's discuss a thread's life cycle. Typically, a thread's life cycle begins with the creation of an instance of the system.threading and a thread class, and it terminates when the thread is stopped or it finished its execution. Now, a thread's life cycle has four states: the unstarted state, a ready state, the not runnable state, and the dead state. Let's go over them one by one. First is the unstarted state. It occurs when a thread object is created, but the thread method is not invoked. Next, we have a ready state. In this state, the thread is ready to execute, but it's still awaiting CPU cycle. Then we have a not runnable state, when a thread is not executable because either the sleep method has been invoked, or the wait method has been invoked, or the input activities are causing a bottleneck. Then, at last, we have the dead state. It is the state in which thread's execution is either completed or aborted. Now that we have thoroughly discussed the thread and their life cycles, we have also discussed a single-threaded model and a multi-threaded model. So now let's implement these models in a Visual Studio Code. Let me move to my Visual Studio Code.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
So let's start with some basic using commands. So using system, then we will have using system dot threading, then we will have our namespace with the name as thread demo. Now let's have a class as public class main thread 1. Now in this thread we will have a static method. So public static void thrd1. This will be a thread name. Let's write code in this function. So we will have a for loop int t is equals to 0, then t is less than equals to 10, then we will have t plus plus. Then we will have a console dot write line thread 1 is then we will place a specifier and put t. So what these curly braces 0 will do is it will replace the curly braces 0 with a t. But when the value of this t is equals to 5, then this method must go sleep for 6 seconds, and after 6 seconds it should resume its working. So to do that, we will have a if statement and we will have t is equals to 5. Then for the curly braces we will have a thread dot sleep and we will have 6000. Now let's create another thread. So we will have another function as public static void thrd2. This will also print numbers from 0 to 10. So for loop int p is equals to 0, p less than equals to 10, and p plus plus I will have console dot write line thread 2 is comma p. Now let's write our main class. So for that we will go for the public class and main thread 2. Then in this we will have static public void main. Then we will call our static methods. So main thread 1 dot thread 1. Then we will again call main thread 1 dot thread 2. Now let's save this and run this program. But first let me explain what this code does. So here what will happen is, first this thread 1 will be executed. Now when t, this for loop will cycle t, so from 0 to it will go to 9, but when t reaches 5, this if statement will be launched, and this will let go this thread to sleep for 6 seconds. This 6000 represents 6 seconds. Now while these 6 seconds are over, this thread 2 is still in the waiting process, so this whole for loop will be on sleep for 6 seconds. After the 6 seconds, this thread will again run, so then it will start printing out 6, 7, 8, 9 and so on, and 10. Then this thread 2 will be started, and then this will go from 0 to 10 straight up. It will not go to sleep because this thread doesn't have this sleep function. Now this is what a good example of single threaded process. Now let's run this. Now as you can see, it has already printed from 0 to 5. Now it's on wait. Then after 6 seconds, it printed out the rest of this thread 1, then thread 2. Now let's write a code for the multi-threading. Let's kill this statement and let's delete everything. Now let's create kill this as well. Let's have a public class main thread. Then we will have a static method 1, so public static void thread 1. Then in this we will print numbers from 0 to 10. So for int x is equals to 0, then x less than equals to 10, then x plus plus. We will write console dot write line thread 1 is CO, comma x. Now when the value of x is equals to 5, then this method should go to sleep for 6 seconds. So we will have again if x is equals to 5, then at that point this if statement will send the thread dot sleep for 6000. Now let's write another static function. I forgot to add space here. Yeah. So now we will have public static void thread 2. Then we will have a for loop which will again print numbers from 0 to 10. So int y is equals to 0, y less than equals to 10, and y plus plus. This will also have console dot write line. Then we will have thread 2 is zero comma y. Now let's write a main method. So we will have static public void main. Now we will be creating and initializing these threads. So first we will have thread as t1 equals to new, then thread for thrd1. Then we will have another thread t2 equals to new thread for thrd thread 2. Now we will start each of these threads. So t1 dot start and t2 dot start. Here what we are doing is we are creating and initializing two threads t1 and t2. Now using this thread class, now using t1 and t2 start, we are basically starting the execution of both of the threads. Now the both of the threads are running simultaneously. What it will do is the processing of t2 will not depend on the processing of t1 like in a single threaded model. Let's see how it will work. Let's run this. Now as you can see, it has run thread 1 from 0 to 5, then it halted, and then it goes to thread 2, then it finished, and after 6 seconds this thread 1 is finished. This is the prime example for a multi-threading function where a thread 1 was started. When it went to sleep after this 5 seconds x equals to 5, it went for a sleep for 6 seconds. Since it went to sleep, a thread 2 which was already running, it started printing out its result. So it printed out its result up to 10. By the time it finished, this thread 1 was also back. So now it was starting running. Then it finished its process, and then both of the threads stopped running.